Welcome back to Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to determine the surface area of a cylinder. In the previous video, we talked about how to calculate the volume of a cylinder. And really, anytime we have volume, it's an easier calculation than surface area. Surface area can be kind of a pain. We'll talk about it here. Here's a cylinder. This is an example of a cylinder that most people probably have in their house of some kind. So a cylinder, like a can of beans or a can of vegetables of some kind or a sauce, it has a top and a bottom, which are both circles, as we see over here. Here's the top, our red circle, the bottom, our blue circle. And those circles are separated by a height h. So that's the height of the can or height of the cylinder, right? And if we want to calculate the surface area, we have to calculate the surface area of each face of the cylinder. So we have to calculate the area of the red circle because that is a surface. We have to calculate the area of the blue circle. That's also a surface. That's going to be the bottom part of our can, let's say. And then basically the label that goes around this, the paper, that is going to be another face. It goes around, completely around the circumference, or the perimeter of the circles, and it has a height h. We need to calculate this area. And the easiest way to think about doing any surface area problem is just to take each part separately and then just add them. So I have two circles here, red and blue. So if I take the area of the red circle and add it to the area of the blue circle, and then add that to the area of the side of the can or the cylinder, this white part, let's say, then that should give me the total surface area. All right, what is the surface area, or just area, of the red circle? Well, it's a circle, so the area is just pi r squared. The same thing goes for the blue circle. That would also be pi r squared. Now, this is the tricky part. If I wanted to calculate the area of this business right here that separates the two circles, basically where this label is, I'm actually going to take the circumference of one of these circles, either one because they're the same, and multiply that by the height. Well, the circumference of a circle is 2 pi r. Okay? So if I were to take the perimeter of either one of these circles, which is the circumference, it would be 2 pi times the radius. And then I'm going to multiply that times the height, and that would get me the area of the sides of the can, or the sides of the cylinder. So let's go ahead and plug in some numbers. Our surface area would be, for the red, would be pi times 4 squared. Now, our diameter is 8 millimeters. Notice we have a diameter and height of 8 millimeters and 10 millimeters respectively. So our diameter is 8 millimeters, which means that our radius is half of that, 4 millimeters. So r is 4, so pi times 4 squared. In fact, it's going to be the same thing for the blue circle as it was the red. So it's going to be pi times 4 squared, because that circle, the blue one that is, has the same radius as the red circle. And then to get the sides of this cylinder, I would take 2 pi times 4, which is the radius, and then multiplied by 10, which is the height of the cylinder. And now I can pretty much just simplify this as much as possible. The first term here for the red circle would be 4 squared, 16 pi. I would get the same result for the blue circle. Its area would be 16 pi. And then over here for the sides, 4 times 10 is 40, times 2 is 80 pi. And then when I add these three numbers, the total surface area is 112 pi, and units are going to be millimeters squared. Remember, volumes have cubic units, whereas all areas, regardless of what type of area, is going to be square units. So here they're in lengths of millimeters, so it's going to be millimeters squared, or square millimeters. And that's how you calculate the surface area of a cylinder. Now, as we'll see in more complicated figures, the best way to tackle any surface area problem, rather than memorizing formulas, is just to take each individual face, and there's 3 here, and think about how you would actually calculate the area of each, and then add them. Because we might run into another type of problem where the bottom is hollow. The bottom is hollow, and so we wouldn't actually calculate or add on the area of the blue circle. It might just be the red and then the sides. So that's why it's not as good to memorize formula, but think about what you're actually doing. You're taking the area of each face here and then adding them. Hopefully that makes sense. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you very much.